Good morning to everyone. Today we will see 12th standard chemistry. See, we are going to complete one lesson. I hope you are following the assignment. And now we will see the electrochemical principle in metallurgy. In the last class we saw about the thermodynamic principle in metallurgy. How this thermodynamic principle are used in metallurgy. Although we are using the thermodynamic principle, some of the reduction of oxide metals like sodium and potassium, it is not possible by using this thermodynamic principle. So we are going to use the electrochemical principle for reducing the sodium or potassium in metallurgy. So we are going to use the electrochemical principle for reducing the sodium and potassium in metallurgy. Here the solution, the metal must be taken in solution or fused form. Here the metal must be taken in solution or fused form. Here one metal which is less reactive will be present in the solution, and the other metal which is more reactive, that will be present, will be move into the solution, or it will form a solution in the less reactive metal. So we are going to see the electrochemical principle that are used in metallurgy. For example, this can be given as delta G naught is equal to minus N F E naught, where del G naught is nothing but standard free energy and N is the number of electrons involved. N is the number of electrons involved in the reduction process, and F is the Faraday, and E naught is the electrode potential of the redox couple. E naught is the electrode potential of the redox couple. Here in the electrochemical principle, if E naught is positive, then G naught will be negative. When E naught is positive, then del G naught, that is standard free energy change, will be what? Negative. If the standard free energy change is negative, then the reaction is spontaneous or it is feasible. When del G naught is negative, then the chemical reaction is spontaneous and feasible. So here the chemical reaction, or it is planned in such a way that this del G naught must come as a negative value, or it is planned in such a way that E naught value must be positive. So the scientists, they have planned the chemical reaction to get E naught as a positive value, then the del G naught will be negative, then actually what will happen, the reaction will be spontaneous or feasible. So when less reactive metals present in a solution is there, we will add one more reactive metal that will go into the solution, that can be given using the equation copper solid plus Ag plus solid. It gives copper 2 plus aqueous plus 2 Ag solid. Then this copper 2 plus aqueous plus zinc solid, here what happens, the more reactive metal will go into the solution, that is it forms copper solid plus zinc 2 plus aqueous. So here this is the electrochemical principle that was involved in metallurgy. Now we will see one other chemical reaction, that is electrochemical extraction of aluminium using Hall-Héroult process. It is a very important naming reaction. Electrochemical reaction involving or electrochemical extraction of aluminium. Electrochemical extraction of Al, or it is known as Hall-Héroult process. Hall-Héroult process. It is an important naming reaction. Electrochemical extraction of aluminium or Hall-Héroult process. Here what we will do, we will take an iron tank lined with carbon acts as a cathode. Iron tank that was lined with carbon. Iron tank that was lined with carbon acts as what? Cathode. Iron tank lined with carbon acts as cathode, and some of the electrode that was dipped in the electrolyte, that is nothing but the carbon electrode that was dipped in the electrolyte acts as an anode. And here, what is the electrolyte taken? It is the extraction of aluminium. So I am going to take alumina, that is Al2O3. Where it is obtained? It is obtained from bauxite. Already we saw alumina plus cryolite. We are adding alumina with molten cryolite with 10% calcium chloride solution. 10% calcium chloride solution. Why we are adding 10% calcium chloride solution? It will lower the melting point of the metal. For that we are adding 10% calcium chloride solution. So what is the electrolyte taken? Alumina, that is it was obtained from bauxite, which was added with molten cryolite. It is an ore of aluminium, and then to that 10% calcium chloride was taken, and it was maintained at a temperature of 1270 Kelvin. These are all very, very important. So only I am writing. There is no diagram in the book, but I am using a diagram to explain. Okay, so the temperature we are maintaining is 1270 Kelvin. At 1270 Kelvin, what happened? Here the impure metal, it is present in the anode, that will pass into the solution. The impure metal that will present in the anode, that will pass into the solution, and it gets deposited on the cathode, that is electrolysis. It gets deposited on the cathode, that is electrolysis. And then what happens? Here anodic oxidation and cathodic reduction. Anode there will be loss of electron, and cathode there will be gain of electron. Anodic oxidation and cathodic reduction. So here ionization take place. So ionization of alumina, how it ionizes? Al2O3 ionizes to give 2Al3 plus 3O2 minus. 2Al3 plus 3O2 minus. So what happens at the cathode and at the anode? For example, at the cathode I told that anodic oxidation, cathodic reduction. So at cathode, aluminium 3 plus 6 electron, it gives 2Al. Okay, 2Al. Aluminium 3 plus 6 electron, it gives 2Al. And then here, it is cathodic reduction, anodic oxidation. So at anode, what happens? 3O2 plus 12 electron. So here anodic oxidation, and here it is cathodic reduction, and it is the overall ionization of what? Alumina. Since carbon is also present, here, because carbon only it is lined as a cathode. So we have to write the cathode reaction also. So carbon solid plus O2 minus melt, or in molten condition it will form CO plus 2 electron. And then similarly carbon solid plus 2O2 minus, which is in molten condition, it forms carbon dioxide plus 4 electron. Carbon dioxide plus 4 electron. So here what happens about the carbon during the reaction? The carbon is consumed at the cathode itself, or there won't be any deposition of the carbon. It will be consumed at the anode and as well as at the cathode itself. So what happens? Here it is not included in the extraction of alumina. So here what happens? We will write the overall reaction as 4Al3 plus 6O2 minus melt plus 3C carbon. It gives 4Al liquid plus 3CO2 gas. So here 4Al3 plus obtained from the anodic reaction plus 6O2 minus in the molten condition, that reacts with carbon to form 4Al, that is aluminium. We have finally refined aluminium and we got the metal plus 3CO2 gas. So this is known as the Hall-Hérold process, and here we are using the electrochemical principle that was involved to obtain the aluminium from the bauxite ore. Now we will see the refining process. 4Al3 plus 6O2 minus melt, or in molten condition, plus 3 solid, it gives 4Al liquid plus 3 CO2 gas. This is the overall reaction obtained at the end of the reaction. That is, at the end of the reaction what we will get? Aluminium metal, which is 99.9% pure. So this is the electrochemical reaction of alumina, or in the electrochemical principle that was involved in the extraction of alumina, or the naming reaction is Hall-Hérold process. We know that in metallurgy there are 3 steps. First one is concentration, second one separation of the metal, and third one what? Refining. And the last step we are going to see is the refining process. In the refining process, we will see the first reaction, first process, that is distillation. See, in metallurgy, last process is what? Refining process. See, in metallurgy, we will get the reduced metal at the end of the reaction. First one I told that concentration or enrichment of the ore. Second one, production of the metal. How it is produced? First step, the ore was oxidized and will get metal oxide. Then metal oxide was reduced to get metal. And the last step, we are going to remove the unwanted impurity. If any other oxide, any other metal is present along with the extracted metal, or impurity that was present along with the extracted metal, we will remove the impurities from the crude metal. That is known as what? Refining process. The process of removing the impurity from the crude metal is known as what? Refining. So we are going to purify the crude metal that was obtained at the extraction. So here the first method is distillation. This is applied for low boiling liquid, low boiling volatile liquid. So this is applied for low boiling volatile liquid. Here what happens? Two processes are involved. First one, the metal will be converted to vapor and then it will be condensed to liquid. So here evaporation or condensation take place. So in distillation there are two principles involved, evaporation and condensation, that will take place. The next one, liquefaction. Liquefaction. This method is employed to remove high melting impurity. High melting impurity from metals having low melting point. Metals having low melting point. For example, the crude metal, it was taken in a sloping hearth. The crude metal, there is no diagram in the book. The crude metal, it was taken in a sloping hearth and it was heated. The crude metal was heated above the melting point. Above the melting point of that metal. So what happens? Here the molten metal is taken in a sloping hearth, slanting position, sloping hearth of the reverberatory furnace. So in that what happens? The crude metal is melted above its melting point, and the metal மேல உள்ள melting point we are going to melt. So what happens? The metal will flow, melt, because it has low melting point, and the impurity will remain in the sloping hearth. Impurity will be here. Impurity will remain in the sloping hearth, whereas the molten metal will come downwards and will collect the molten metal. So this is how we will purify the crude metal and remove the impurity. So this is the second method, that is liquefaction. Then third method, electrolytic refining. Third method, electrolytic refining. Third method, electrolytic refining. This is very easy to learn. The only thing you have to remember which is anode, which is cathode, and what is the electrolyte that was used. So this is electrolytic refining. So here what we are going to do, I am going to explain it using an example. For example, here one electrolytic chamber, this is known as electrolytic chamber. Electrolytic chamber is taken, or simply beaker. Electrolytic chamber was taken. In that pure silver, impure silver is taken as anode. All the time you have to take the impure metal as anode. Impure silver is taken as anode, and pure silver is taken as cathode. Pure silver is taken as what? Cathode. And here acidified aqueous silver nitrate solution. Acidified aqueous silver nitrate solution is taken as the electrolyte. Acidified aqueous silver nitrate solution. Acidified aqueous AgNO3 solution is taken as the electrolyte. Acidified aqueous AgNO3, it is taken as the electrolyte. So I told that all the time you have to take impure anode as the impure metal as the anode and pure metal as the cathode. So here we have to take the electrolyte. Which electrolyte? Acidified aqueous silver nitrate is taken as the electrolyte. Now what we are going to do? What happens in anode? In anode, I told that anodic oxidation. So oxidation involves what? Loss of electron. Cathode, cathodic reduction. Every time you have to remember anodic oxidation, cathodic reduction. So here what happens? The electron will move into the solution. The ions will move into the solution and then it gets deposited on the cathode. The pure metal will get deposited on the cathode. On passing an electric potential, what happens? The electron will move into the solution or the ions will move into the solution and then it gets deposited on cathode and the impurity will be left down as anode mud. And the impurity will be dipped down or left down as anode mud, or it will be left behind the anode as anode mud, or it is left down the anode as anode mud. So this is the principle in what? Electrolysis. Everywhere, anywhere when you see electrolysis, you have to remember anode is impure metal, cathode is pure metal, and anodic oxidation and cathodic reduction. Now we will write the anodic reaction. I told that anodic oxidation. So anodic, what happens? Anodic oxidation. So Ag to Ag solid. Ag solid, it gives Ag plus 1 electron. Here there is loss of electron. I told that anode oxidation. What is oxidation? Oxidation is a process which involves loss of electron. So Ag plus 1 electron. This ion gives 1 electron. Then what about cathode? Cathodic reduction. So Ag plus 1 electron. Here it has gained 1 electron. This Ag has gained 1 electron and forms Ag solid. So anodic oxidation and cathodic reduction. And this method is also used to purify copper and zinc. This method is not only used for silver, it is also used to purify copper and zinc. Again I am saying impure metal is taken as anode, pure metal is taken as cathode. Anode, what is the principle? Anodic oxidation, cathodic reduction. This you have to remember. Then you can easily write the equation, that is anodic oxidation, it involves loss of electron. So at the product side you have to show the electron, and the cathode, it involves reduction. So at the reactant side you have to add 1 electron. So we will get this equation, and this method is applicable also for copper and zinc. Also it is used to purify copper and zinc. So I hope you understood this electrolytic refining. The next one, zoned refining. Zoned refining process. Here also no diagram is there for zoned refining. Zoned refining. Here the impure metal is taken as a rectangular bar. If you want, you can draw the diagram. Impure metal is taken as a rectangular bar. The principle used is fractional crystallization. Fractional crystallization. These are the key words. See, when you are writing the exam, you must see you have written all the keywords. So this is the principle involved is fractional crystallization. You take a rectangular bar, and then in that bar I am going to connect a mobile induction heater. Okay, mobile induction heater. Here we are placing a mobile induction heater, and here what happens? The impurity will be present in molten condition, or impurity will prefer to be in molten condition, or impurity will be in molten condition. And here when I am moving the mobile heater, this part will be pure. This will undergo crystallization, and this will be pure, and this will be what? Impure. So the impurity will be in the that is the molten condition, that is in the mobile induction heater. Below the mobile induction heater it will be impure. When I move the heater, the metal obtained or the bar obtained will be pure. And here it must be maintained in an inert atmosphere. These are the key points. So this experiment must be maintained in an inert atmosphere. If you want more pure metal, you have to repeat the procedure once, twice or thrice. And then this method is applicable to purify semiconductors like germanium, gallium and silicon. So this method is used to purify or refine this germanium, gallium and silicon, which is used as semiconductors. So this is what zoned refining. So zoned refining, what you have to remember, a rectangular bar which is taken as the impure metal. I am going to place a mobile induction heater and the impurity will be in the molten condition, and here this will be pure and crystallized, and we have to carry out the experiment in an inert atmosphere or in the presence of inert gases, and this method is used to refine the semiconductors like germanium, gallium and silicon. So this is what zoned refining. This can be asked in long answer. Now vapor phase method we are going to see. Then fifth one, vapor phase method. Fifth one, vapor phase method. So in vapor phase method, what is the principle? Here the metal is fused with another metal, fused with another substance to form a volatile substance, and that volatile substance will be converted into a metal, pure metal. So this is what the vapor phase method, and in that I am going to explain Mond's process. Mond's process for refining of nickel. Mond's process for refining of nickel. Nickel plus carbon monoxide or nickel in the surface, nickel carbon monoxide is allowed to pass, a stream of carbon monoxide is allowed to pass over nickel at 350 Kelvin. Allowed to pass over nickel at 350 Kelvin, and it forms a more volatile substance, nickel tetracarbonyl, and then this nickel tetracarbonyl, when it is heated at 460 Kelvin, it forms pure nickel. Pure nickel. It forms pure nickel. So this is our Mond's process. Then Van Arkel method for refining zirconium or titanium. Van Arkel method. Van Arkel method for refining zirconium or titanium. Van Arkel method for refining zirconium or titanium. Here titanium, when iodine vapors, iodine are passed over titanium at 550 Kelvin. It forms a volatile compound, titanium tetraiodide. Then this titanium tetraiodide, it is passed over tungsten filament. It is passed over tungsten filament at 1800 Kelvin. It forms titanium plus iodine. And this iodine can be reused at the end of the reaction. This is known as the Van Arkel method. And now we will see the uses or applications of some metal. Application of aluminium. Application of this aluminium. See, this aluminium is used in cooking vessels, in preparing cooking vessels. Cooking vessels. It is used in overhead cables to prepare wires or overhead cables. Since it is very strong, it is alloyed with other metal. It is alloyed with other metal, that is aluminium plus magnesium plus manganese plus copper. It can be alloyed either with magnesium, manganese or copper, and it is used to prepare aeroplane parts. Aeroplane parts. And it is used as a wrap to prepare packing material, or used as a wrap to pack the food items. So these are some of the uses of aluminium. Then uses of zinc. Zinc is used in galvanization. Zinc it is used in galvanization. What is galvanization? It is coating zinc over iron sheets. Zinc is used in galvanization. Then zinc oxide. It is used in paints paints, then rubber, and then cosmetics. So in cosmetic, what is the use of zinc oxide? It is used as a sunscreen. It is not in your book. It is used as a sunscreen, lactocalamine, zinc carbonate, zinc oxide. It is used as a sunscreen. Then zinc sulfide. It is used in X-ray screen, fluorescent lights, and as luminous paints, and it is used in automobiles also. This zinc is used in automobiles because it is very much used to prevent this rusting and corrosion. The next one, copper. Copper, we know that it was used in the ancient time itself. From the Bronze Age itself, this copper is used. And one important thing is, we will call coinage metal. This copper, silver, gold is known as coinage metal. Why it is known as coinage metal? It is other important one word. Why it is known as coinage metal? Because it is used to prepare coins. Copper, silver and gold is used to prepare what? Coins. So it is used as coinage metal. This copper is used to prepare wires. Copper wires, boilers, then calorimeters are prepared from this copper. Then here, what is the use of this copper? Why it is used as wire? Because it is a good conductor of heat and electricity. Copper, it is a good conductor of what? Heat and electricity. And now next one, iron. Iron is also used in preparing different articles, and here this iron which is its alloy, iron alloy, that is stainless steel. It is used to prepare surgical instruments, cooking vessels. Then nickel steel, it is used to prepare these aeroplane parts. Okay, already I told that this aluminium is used to prepare aeroplane parts. So that is one word. The nickel steel is also used to prepare aeroplane parts. Then chrome steel, it is used to prepare cutting tools. Cutting tools and crushing machineries can be prepared from chrome steel. From chrome steel we can prepare cutting tools, and crushing machineries can be prepared from chrome steel. Crushing machineries can be prepared from what? Chrome steels. So these are some of the uses of what? Iron. And next one, the uses of gold, very very important. This copper, it is also used to prepare cheap jewelry. What is cheap jewelry? Gold will be 1% or something, and copper will be more. The amount of copper will be more. So copper is used to prepare cheap jewelry. Now gold alloyed with copper, it is used to prepare jewelry. 916 gold. Okay, 91.6% will be gold and remaining will be copper. So gold, it is used to prepare jewels, or it is used in jewelry, and it is used as a standard for monetary systems. It is used as a standard for monetary systems. It is used as a standard for monetary system. Then thin film of gold, 1 gram plated gold, we know. Thin film of gold. It is used to prepare, or it is used to coat a layer of gold in watches. Thin film of gold. It is used to coat a layer of gold in watches. Then dental filling. What is this dental filling? Artificial tooth can be prepared using this gold. Silver is also used in dental filling. It is not mentioned in the book. Silver is also used in dental filling. Silver amalgam. Silver alloyed with mercury is silver amalgam that is used in dental filling. Then this gold is also used in dental filling. Then colloidal gold is used in medicine. Colloidal gold is used in what? Medicine. Colloidal gold is used in medicine, and it is also used as a catalyst. It is also used as a catalyst. Gold is also used as a catalyst. So these are some of the uses of gold. So we have learnt the application of aluminium, then zinc, then iron, then copper and gold. And I hope you understood the today's class. What and all we have seen. Electrochemical principle in in metallurgy. Then in the electrochemical principle we saw electrochemical reaction of aluminium, that is extraction of aluminium. The next one we saw refining process, different refining process. What are the refining process? Distillation, liquefaction, electrolytic refining, then what? Then zoned refining. Then in the vapor phase method we saw two methods, Mond's process, Van Erkel method. Then application of some important metals like what? Aluminium, zinc, iron, copper and gold. So I want you to learn for tomorrow's homework, I want you to learn the application of the metals and write as an assignment. Application of metal, it is very easy to learn. Application of metal you write and learn. Application of metal is the assignment I am giving it to you, because we will get many one word and it can also be asked in short answer and long answer. Application of the metals. What are the metals we are having? Aluminium, zinc, iron, copper and gold. So these and all you write, learn and write. So this is the assignment for this class. And finally we have completed one lesson, that is metallurgy. I want you to study the everyday portion every day. It is not a matter to teach, because it matters when you learn. So you don't postpone the everyday's lesson, you write all the assignment. Apart from the assignment you study the everyday portion also. I find only one or two of the students are answering and they are writing the assignment. I want everyone of the students to answer the assignment or complete the assignment work. So today's assignment, you learn and write the application of metals, these 5 metals. Don't postpone the everyday portion. If you postpone, at the end of the year you find difficult to study. So you study the everyday portion, write, learn and write. Thank you for listening to me. Thank you.